Okay, so I'm doing problem 52. If 72.4 kilojoules of heat is applied to a 952 gram block of metal, the temperature of the metal increases by 10.7 degrees Celsius. Calculate the specific heat capacity of the metal in joules divided by gram degrees Celsius. So specific heat, the units are joule over gram Celsius. Now, so far we've just done these problems using dimensional analysis, our crossroads, right? Like do this. Oh, we want joules. We're gonna have joules on top and grams, degrees Celsius, that dealio. Let's just come up with an equation for specific heat, and we can do that by just analyzing the units of specific heat. So I'm gonna get rid of this, and I'm gonna move our units. So these are the units. Oh, don't want to move that. I'm gonna use units. Move these down. So joules is actually just the units for energy, right? Just going to put that on top. Energy's on top. That's over grams, and grams is a measurement of mass, times degrees Celsius is just the measurement of not just the temperature, but the temperature change. So up here it's like an increase of 10.7 degrees Celsius. So it's a change in temperature. And how you write change in temperature is delta T. The T stands for temperature. And the delta, that's a Greek symbol, it stands for change, or the difference in. So change in temperature. So let's use that equation instead of dimensional analysis. We can still do dimensional analysis analyzing the units, but I think it's easier if we just use this equation. So let's go back to the problem here. I'm going to erase this. I'm going to move the units over here. Move these off to the side. And let's use this equation. Let's just plug into this equation. So the specific heat, I'm going to abbreviate a little bit, will equal my energy. I look up here in the problem. My energy is 72.4 kilojoules. The mass, that's another thing I need to know, is 952 grams. And the change in temperature, delta T, increases by 10 degrees Celsius. So that is my change in temperature. It increases, so it changed from one thing to another by 10.7 degrees Celsius. Alright, so I have all of the unknowns except for specific heat, which is what we're trying to find. Specific heat is what we're trying to find. So I'm just going to plug into this equation right here. Specific heat equals my energy, which is 72.4, and I'll go ahead and write the units. That's kilojoules. What do I need to do to that? They wanted to know the answer in joules over grams degrees Celsius. So I need to change, move it back up, I need to change my kilojoules into just joules. So 72.4 kilojoules is equal to 72,400 joules. You can do a conversion factor if you want. I just know that from analyzing it. So let's plug that in. 72,400 joules. That's going to be on top of my mass, which is right here, 952 grams. And also on bottom is the temperature, which is 10.7 degrees Celsius. Okay, so all I'm going to do is take 72,400, divide by 952, and then take that answer and divide by 10.7 degrees Celsius. So we clear this. 72,400 divided by 952 equals and then I'm going to divide by 10.7. So that's my answer there, 7.1075, and continues. That is my specific heat. For sig figs, if it's 72.4 here, 952 here, and 10.7, those all have 3 sig figs to them. That's the numbers I'm working with. So I need my answer to be 3 sig figs. So the answer would be 7.11. 7 makes the 0 round up to 1. So 7.11. And the units, if I analyze the units here, it's joules over gram times degrees Celsius. Joules, gram, degrees Celsius. And that's what I wanted. I want my answer in joules over grams degrees Celsius. And so that's my final answer. So you could also use dimensional analysis, but this way I think is much easier. So that's problem number 52.